Alright, welcome back. We are almost done going through the answers to this homework. We'll start where we left off. It says, write your definition in one square, provide examples of the word in one square, non-examples in one square, and a picture representing the word in the fourth square. Colligative properties, we first have to provide a definition. Now the definition of colligative properties, if we edit the text here, colligative properties are any properties that depend only on the number of dissolved solute particles in a solution, meaning that they're the properties of a solution that depend on how much solute you've dissolved. We really only learned about two of them, and I emphasize that you did not need to understand all the complicated physics. You only needed to understand the big ideas. The two colligative properties that I asked you about are the two that are listed on the Wikipedia page for colligative properties. Hey, look at this, colligative properties. If you look down here, colligative properties are properties of solutions that depend on the number of molecules in a given volume of solvent, and not on the property or identity, e.g. size or mass, of the particles, or the molecules. If you look down at the contents, it says that the two big ones are boiling point elevation and freezing point depression. You remember me talking about that? Boiling point elevation, freezing point depression. That is all you need to know in terms of colligative properties. They are properties that depend on the number of dissolved solute particles. Down here, as far as non-examples go, things that are not colligative, they're really any other properties of the solution. Color, temperature, the density of it, anything besides those two, in terms of your test on Friday, not colligative properties. Now, in terms of a picture representation, what could we put for this? Well, the two things that I talked about were boiling point elevation and freezing point depression. For pictures of that, I might say that things that, we've used, let's see if I look up boiling point elevation, let's see what pictures people have used for this. These graphs are sort of confusing, but what I would say is that if we look at this one, we can remember my description of how water tries to boil, but when you put salt in the way of those molecules, it's harder for them to escape and to boil off, and that elevates the boiling point. If we look at, say, freezing point depression, we can imagine salt on icy roads. And we can look at a picture of, say, a bunch of dump trucks dumping salt on icy roads. And the reason we do this in the winter, and I know you guys have never seen one of these in Texas, but in Chicago we see these all the time. Dumping salt on the ice helps lower the freezing point of the water, and it makes that ice actually melt, which makes the roads a lot safer. Alright, going down a little bit, we've got our very last questions. Now, we emphasized the solubility chart in class today. Hopefully you got some practice with that. It says, use the chart at the right to answer the following questions. At 40 degrees Celsius, okay, I'm going to highlight the important parts. At 40 degrees Celsius, how much potassium nitrate can be dissolved in 100 grams of water? Now, there's the three important parts of answering this question. First of all, before you can do this, what's potassium nitrate? Well, we look on here, we know potassium is K. So it's either this one, KClO3, this one, KNO3, this one, Ki, or this one, KCl. Well, it's potassium nitrate. Hopefully you guys remember that nitrate is NO3. So when we're talking about potassium nitrate, we're talking about this curve along here. Now it says at 40 degrees. You have to start with the temperature. Down along the bottom axis of this graph, we've got temperature. So right there is 40 degrees. We're going to follow that line up until we hit the KNO3 or potassium nitrate line, and then we're going to follow it over to about 60 grams, because remember that this axis shows grams of solute that can dissolve in 100 grams of water. So we would say about 60 grams of KNO3. And if you want to be fancy, you take that little 3 and you make it a subscript. Now the second question asks, at 40 degrees Celsius, how much potassium nitrate can be dissolved in 400 grams of water? Now this is almost exactly the same question, but you have to see here that it is talking about 400 grams, not 100 grams. 4 times as much water. Now if we know that 60 grams can be dissolved in 100 grams of water, how much could be dissolved in 4 times as much water? Well, the answer is 60 times 4, which is 240 grams of KNO3. Again, I'm going to make my little fancy subscript. Now, if you can do this one, you should be able to do 3 and 4 on your own. Alright, get that homework done and turned in tomorrow, and tune in next week for some more help. See you tomorrow.